So last day we have discussed about this linked list, but not the implementation. According to your book, actually, so it has various right operations on linked list. So this is what we discussed last day. And linked list not like unlike this list and the arrays. So basically, it has flexibility to add. So it is not static. You have flexibility to add any number of lists until your hardware permit permits. So you can add any number of nodes to the linked list. Basically, in a node, you have so two things. So one thing is node data, and the second thing is pointer to the next node. The first thing is data, and second thing is pointer to the next node. And there's something called head node. So that is the starting point, and there's something called tail or the rear. So basically, rear uh, will be the last point. Last inserted node will be at the rear, and the first, or you can mention the other way. You can say so if it is head is having the last inserted node and tail is having the first inserted node. So you can define it either way, right? Or you can say tail is having the last inserted node and head is the first node. Likewise, you can define that. You can define that, but generally, uh, it is like you can insert. So easy to insert from one end and easy to remove from the other end. So that is basically this linked list are easy. So when you are using data structures like queues, because queues, queues are like first in, first out. Whatever inserted first should be removed first. So implementing queue will be easy by using a linked list, right?
Right.
Because you have to access the linked list nodes in sequential manner, one by one by one. You have to start accessing from the head, or you can say either a tail or head. So whatever the last position, and you have to go one by one by one by one. So then only you can access all the nodes. That is called actually linked list traversal. Linked list traversal. Okay, let's see. So this one is where the new node is inserted to the beginning of the list. So let's say head. So new node is inserted to the head or the beginning of the. So that can be done by just reference in the new node. So removing the existing head node and reference in the new node, which is then pointing to the this node. Actually, what you have to do first, you have to first reference this one to be A to B node, and then you have to reference head to A node. So then this will be automatically removed or discarded. So first, let's say head is B. Head B here. So if head is B, this is head, right? Head is pointing to the B. So that means the first node is B. So now we are going to insert node called A. So you have to tell that node A pointing to B. Node A pointing to B. Then you have to tell that head pointing to A. So that's how the insertion from the front can be done. And insert into the rear. So rear node is basically pointing null pointer because you don't have anything after that. Right? You don't have anything after that. This is called null pointer. So it's referring to the last node. So when you insert from the
Mhm.
last node, it's easy. You have to take the last node, which is pointing null pointer, and insert the new node with the null pointer. That's easy. No need to break any links. So you just want to insert to the rear or the last, insert to
Right.
the last node, right? Insert to the middle actually would be little bit of complex because you have to first go and find the node where you need to insert that. That must be done one after, like access in sequential order. After finding the node, so similar to this one, you have to point the new one, point the new node to the, let's say C is going to be inserted in the middle. So C will be pointed to D, then B will be pointed to C. By doing that, pointer from B to D will be automatically removed. So hope you understood that concept.
Right.
Any difficulty or any issue in the concept?
No.
Right. What about removing? What about removing nodes? Again, removing node from the rear will be easy. What you have to do is just point the null pointer to the one before the rear node. So if you want to, for an example, if you want to remove L, the last node, you have to just put null pointer to the D node and automatically L will be detached. So if you want to remove from the beginning of the list, so you have to promote the head to the next node, and head will be pointed to maybe C node. Head will be pointing to the C node, and that will remove this node. And removing from middle also important. So when you want to remove from the middle, again you have to link. Let's say you want to remove D node, then you have to first actually create. So you have to point B node to L node directly. That will remove the node D from. So if you point B node to L node directly, that will automatically remove D node. Right? Those are the removing part. Right? Here you can see the deleting part. Deleting part, in deleting node, the we'll copy the pointer field of the node to be deleted, right, into the pointer field of node B. To delete D within the list, we copy the pointer field node of node to be deleted, that is D. You copy this one to this one. You copy this one to this one. Means this will be linked into L node. Understood?
Right.
Right. So further, if you want, like, okay, let's say here you have, let's like this, right? Here you have pointer to L node. Here you have pointer to L node. So that's how the link is there now. So if you copy this, to this one, so here you have a link to D node, right? You just remove this and copy this one to this one. So now B will be linked into L node. That's the meaning of that. Understood?
Right.
Right. Okay. So you have to learn basically deleting, inserting, and creating the. You have to know the deleting, inserting, and creating of the nodes. So basically the implementation part. How to implement a linked list. So it's there. Creating a new linked list. Right. Then so basically inserting node to that. Inserting node, new node. So the inserting can be done to the front or the rear or the middle. Then so searching. So I will learn with the deleting part and then deleting, right? So that access to all nodes or listing all the nodes. So those are the operation to be learned in this. Today what we are going to do is we are going to implement this and learn one by one. Okay, so don't read everything at once. Right? So this is basically the full implementation of this. But let's say, so we are going to use object-oriented concepts because that will be easier, right? Object-oriented concepts will be easier to use when implementing this kind of thing because, so node is, you can say node is a class, right? Node is a class. So I think you know the object-oriented concepts already. Do you, or do I need to recap? Double OP. Yes.
Could you recap, sir?
Okay, sure. Right, okay, let's go in object-oriented concepts, double OP. You have something called class and something called object. Class is basically a blueprint or template for a set of similar types of objects. Class is a blueprint or template for a set of similar type of objects. For an example, okay, think about student. Right? It has attributes and methods. Okay, think about student. Right? So if class name, let me create class. So using this kind of table, or so can be a diagram like this, right? Not just a table, it's a diagram, but it's easy to do with a table. Let's say I'm inserting a table. Let's say student class. So what are the features or attributes? Features or attributes of the student related to system point of view. So please consider according to a system point of view. If you are a student, you are going to register in a system. Let's say you are going to register for a course in an institute. And what kind of information you need to give?
Student name, admission number. No.
Yes, your student number or admission number. And what else?
Class.
Contact number. And maybe if you have an IC, that is also the address. So those are some primitive. There are more, but for an example, you have to select a course, or you have to select a grade. Likewise, you have many other things. But basically, it's these things. These are called attributes of this class. These are called attributes of this class. Then, in the other hand, you have some methods. So, for an example, you can register with the institute. You can do payment to the system. You can do the payment, and maybe to the system you can do exams. So, some kind of things: register, do payments, do exams. Maybe you can mark attendance through their barcode system. That is also a method. Methods are basically indicated method name with brackets. So that is the usual method of representing a method, because inside the bracket there is a function, or method means a function. In a function, the parameters can be given. We have discussed about functions in Python. Therefore, to make room for these parameters, we are keeping these brackets. Okay, so this is basically class. If I ask what is student name, can you tell me student name and telephone number? Can you tell those? What is the student name? What is the telephone number? Yes, what is the address?
What do you mean, sir?
Yeah, can you tell me the values? So telephone number, NIC address. Oh, so is values are there or not there in the student?
They are.
So what are the values then? What is the student name?
Like the format of what should be there?
No, I'm asking what is the student name? Tell me the name of the student.
Should I just give a name?
You can give a name, then it is not the name of the student. No, it's a name. And the, I think you know the difference, right? I'm asking the name. Okay, you can see name. What is the name? Can you tell or cannot?
Yeah.
But you can give examples, no?
Yeah.
Yeah, you can give sample data, examples. So name is, let's say name is like Siddhas, and you can say student number is some number, and telephone number is some number, and you can say NIC number is some number, like, okay, address is some address. Likewise, you can tell the values. If you can tell the values, it is object. It is not a class. Class is basically here blueprint or template. You know these values will be there, but you can't tell the values. Understood what you mean by blueprint or template? It's just a template. Right? In template, you don't see actual values, but when you create something using this template, okay, Siddhas is one student. You can create another student. Maybe Samira is another student. Gayan is another student. Maliti is another student. Likewise, you can create, maybe John is another student. Likewise, you can create any number of students using the particular template. But template for these, all these students will be same template. You can follow the template and create any number of objects. So that is called object. Object is an instance or real life representation of a class which has values. It has values and real implementations. Not just value, you have real implementation of method that Sedas can register. So he can do the payment, do exams and mark attendance. Can do all these things. It has value as well as the implementation. Okay, so I think you have to write down if you don't know. So better you write down.
Yeah.
This is the basic concept. You have objects and classes. In object-oriented concepts, you have objects and classes. Kindly write this. Okay, after learning this, basically you have some more concepts. So I think this you have a separate lesson for this, for OP, object-oriented concepts, but let me give you a few. So there are more related concepts when coming with this OP. So first in this, the beginning of the lesson, when we start Python, we discuss about sequence. So where the instructions are executed one after the another. Selection. Instructions are, the instruction flow is selected based on a condition, and repetition. So instruction flow is repeated according to certain condition. According to a certain condition, instruction flow is repeated one after. So like it's repeating same place, but until a certain condition satisfaction, or until a certain condition. So that is called repetition. So in those cases, we basically learn the implementation, how this happened. But in OP, it looks some broad aspect. For example, okay, you think how a student register. So student will give to the front office, will give the first name, after last, middle name, then the last name, then address, date of birth, telephone number, parent contacts, all these things are given. Then receptionist enter this to system after one by one, then insert the system, generate registration number. After generating the registration number, then receptionist will inform, then student do the payment to the registration number. That is set of processes. So that concept is called procedural programming. So it focuses on what is going to happen next. What will happen next? That is procedural programming. That's what we did during those examples, during that discussion in the Python. In Python, basically we learn operators, how to apply that, the process, then we learn sequence, selection, repetition, the control structures, then the function, everything is belongs to the procedural programming. But in here in object-oriented programming, we think about who are the participants, what they do, how they pass messages. That is broad aspects. It's a broad aspect. Who are the participants, what they do, how they communicate. That's all. Inside that, you have the implementation. Register, it can be a sequence of selection. Do payment, some sequence of selection. We don't care what are those. We care about the participants. So that is called OP. Understood the concept, two concepts?
Yeah.
Right? One concept is focusing this implementation. The second concept is focusing the participants. Right? Here actually we have some another additional things like you have inheritance. For an example, if you create like a S-level student, AS student, still having the same, right? Example, a student still having the same thing, right? Same, this is the template. But for AS, some subjects are different. Right? Then when you come to AL student, there is another. So those are Actually, from student, you can create AS student, AL student both. So then both AL student and A student get the features of, right, both AL student and A student will get the features of general student. So both of them have name, telephone numbers, NIC addresses, courses. Both of them will register, do payment, do exams, mark attendance. But both are having those common features. In addition to that, they have special features which is unique to them. Understood?
Yeah.
Right? What is the advantage of inheritance? What is the advance of inheritance? These two will inherit from student class. Any advantage of inheritance which was not there in procedural programming? Any advantage of inheritance which was not there in the procedural programming? What is that? Anything?
Uh,
Do we need to write this code again? Do we need to write the code related to student? Do we need to write it again in the AL student and A student separately? Or you can inherit?
Inherited.
Can inherit. Right? So it will minimize code replication and save our time and effort, because you no need to write the code again. So it will minimize code replication or code, so synonyms, so duplication or replication, whatever. So it will save, actually it will reuse the code. Right? It will reuse the code by its parent. So that is the advantage of inheritance. Likewise, there are many other concepts like polymorphism, overloading, overriding, encapsulation, constructors. So there are many, but we'll discuss in the relevant lesson. So for the moment, we need this basic idea about object and class. Okay. Now let's go to the linked list. So this class, you call class linked list as the node is a class. What are the features belongs to node? What are the features belongs to a node? Yes, you saw in this. Come on, you saw in this. Node has two things. What are they? This is a node. Node has two things. Yes. What is this and what is this? What is the first cell? What is second cell? Yes, node has two things.
Yeah.
The node's value, the data value, and pointer to the next node. Right? Data value and pointer to the next node. Okay, that can be given as this. So it has a data value and a pointer to the next value. Initially, when you have like empty node, you can say data value is empty. This is default. By default, if you not give any value, data value will be empty. None means empty. At the same time, if you have only one item in the linked list, so pointer to the next node will also be none because no pointer. It's null pointer. Here you can see if there's only one node in the list, it is null pointer. Assume that no other nodes are there. If you have only one node, that node is this one. You have one node and that node is this one. Then you have node and the null pointer only. This is null or none. None. It is none or null. And if value is not for anything, you can define a node like this. So by default, you can see by default the data value is none. And okay, then So this data value is given to this value, and self next level will be. And what about the linked list? Linked list? Linked list consists of nodes. So it has special thing, that is their head value. This one, start pointer.
Yeah.
List list has this start pointer. In list you have the start pointer only. Okay, that is basically that is head value is null because nothing is there. Okay, so then let's go to the creation part of the linked list. Linked list can be created this way. List equal, so just let's do one by one, right? Without, otherwise it will confuse you. So let's take a new file, and this is our linked list. So creation can be done in this way. Let's say in linked list you are going to insert days, and linked list will be empty linked list. When you call this linked list class, yes, this is the class name. When you call the class with brackets, it will call this init function. So this init function is called constructor, right? It's called constructor. Constructor will create object of that class. Similar to that, here also you can see in the node class, you have the constructor, it will create object of that class. Okay, when you call this function with brackets, it will create linked list, but this linked list will be empty. It has head node, which is pointed to none. That means empty linked list, nothing is there. Then I'm telling, okay, I'm creating a new node, let's say node 1. Node 1 is new node, you can say new node, this one. Right. Node is node class. Again, calling the node class and creating a new node. And that node has a value, data value. The data value is Monday. So you can give like this, right? If you want, you can give like this. Then empty node will be created. Empty linked list. So similar to empty linked list, it will create empty node. But I just want to give a value. I'm giving Monday to this one. So it will create a node. And if the data value of that node is Monday, then I'm the head value, I'm linking that to node 1. Head value I'm linking to the node 1. Right, then you have to add the other nodes. This is like, okay, so let me write down a step, creating empty linked list, creating node with node object, actually list object here, right? Creating node object with data value Monday. Here actually adding node 2 to the linked list. Now linked list object has one node. I just want to add some other nodes. Okay, so this is creating another node. Actually, we have created 2 nodes. Now we just want to add these nodes, right? We need to add these nodes. You can call like, you can say node 1. Actually, to the list you have to add, right? Sorry, list 1, and list 1 has like, you can say list 1 has head value, and you know head value is anyway node 1, and head value, then head value again next value of the head value, that is this one. The next thing pointing is, you can say that is e2 is the next pointer, and then you can say, right, how to add the next one. You can say, right, Now you know E2. E2 is the second node. You can say its next value. E2's next value is E3. So likewise, you can add further, right? So shall we create this linked list and add these nodes quickly?
Right.
Let me save this as let me save this as ll.py linked list. To run the file. Okay, nothing will happen because I have not done anything, right? Oh, I can just start. I can try to print this list one, right? But it will show. So list one basically it will show it the memory location of the list one because this is a class similar to function. It shows the object is there. Sorry, object is there in this memory location. So if I say str to list1, so still I get this one. How can I access the values of this list? How can I print the values of this list? Yes. How to print the value of this? If I print like this list.head value, what will happen? Head. Again, it says the node object. Now you found the node object. So, but if you say in the node object, I'm referring to the data value. Now you can say Monday. You have to access the data. Head value data value. In head value, you have the data value Monday. Or head value, you can say next value. Next value. Head value next value is also a node. But if you say head value next value data value, you can say Tuesday. If you want the next value, you can say head value next value next value. That is also a node. But if you want the data of that, I can say head value next value data. So likewise, you have to access data. Now you can print Monday, Tuesday, and Wednesday. You have to go like the first node, second node, third node, data value. First node, second node, data value. First node, data value. So I think you understood the concept. So shall we try this quickly? Ikman අපි මේක ලියලා බලමු. Okay. If you cannot understand anything, please ask right. Then I can explain again.
All right.
Take any node. So any node having two things, that is the data value and the pointer to the next value. Simple concept. And linked list has a special thing, that is the head value. That is the starting point. So starting point in is the first node basically here. You can say starting point in the head value is pointing to the first node, the very first node. So the next nodes are relatively pointing to the each other. So node 1 is pointing to, so node 1, the next value of node 1 is node 2, right? Or you can say head value, next value is E2, and in that E2 nodes next value is E3. E2 nodes next value is E3. Likewise, you can add the components, right? Add the components, that is possible. So if you want to add another new node, let's say E4, E4, let's say node, and I'm adding someday. If I want to add this someday to the next node, I can say E3, E3 of next value of this E3 is E4 node. Right? So that's all. Then if I run this code, I can ask what is the lists, head values, next values, next values, next values data. That is basically someday. So it's very easy to add nodes to this chain. So now next is about print in all nodes. So next function is about print in all nodes. So I'm using this function which I have already written here to print these nodes. So that is this one. I'm adding this function to the linked list class. So this is list print. The method name is list print. And print value, it is starting from the head value. Self means the same class, same object. So referring to the same object. So that is head value. Starting from the head value, while print value is not none. Print value is not none means, so last node you saw, this is none. This is pointing to none. Right?
Yeah.
When this is pointing to none, so you are done. Right? When print value is not none, right? So print value is not none, the head val, starting from the head val. If head val is none, what will happen? Head val is none, nothing will print. But if head val is not none, right, then you can print the print values data value. That is this one, print values data value. And then you can change the print value to the next value. You can print the data value to the next value. So that's what you're going to, it's very simple. So let's use this now. After this, I can say list one dot, I can call the list print function. So then you can see, okay, let's run this. Okay, saved, run this. You can see Monday, Tuesday, Wednesday, some days printed. So access it one by one until this become none. So that is very simple. Okay, I invite you to write two things. That is def. So just give a try after writing this, right? First write this, then give a try to write def insert front method, and you have to insert some item like insert front. Maybe you can give the item, say some day, another day. Try to write this function. I'm going to comment this. And try to write the second function, which is insert rear or insert back or insert rear some other day, another day. So try to insert to the front and insert to the rear. So please write this list printing function and try this. And always, again, you have to give a try to insert to the last or insert to the front or the head, insert to the rear. Okay. So rear means the back side. So the E4 is in the rear. So you have to assume like that, E4 in the rear. E1 or this list, node 1 is the first node. Node 1 is, or you can say, simply you can say E1 is the first node. E1 is the first node, E4 is the last node. Try to insert before E1 and try to insert after E4. After writing this, I'll give you like 5 minutes of time. This you have to learn actually. That's why I'm giving this to you to try. Then I'll explain. So give a try like 5 minutes. So what about the next two? So that is insert to the front and insert to the rear. Sorry, insert to the rear, not rear. It's insert to the rear. Insert to the front and insert to the rear. So you can define these two functions. So when you insert to front, we saw in your note, right? When you insert something to the front, what will happen here? So first is the new node will be pointing to the right here. So start pointer is copied to the new node. So start point of this one will be copied to the new node. And then here you can read this clearly, right? It's clearly mentioned. A new node is inserted at the beginning of the list. The content of start pointer. Start pointer means this our head is copied to the new node. Head pointer
Yeah.
will be copied here, right? And start pointer is set to the new node. Then head will be the new node. New node will be the head. So that's what you have to do. So when you are starting a new node, when you want to insert another day or insert some other, so what you have to do is create a node. So here you can see, right? You have to create the node with this data, right? Here, create the node with this data. So you have to take this data another day or someday, whatever. Let's use, okay, self means referring to the same object. And then you have to give the data to insert the particular node. And you have to create a new node using this node class, right? You have to create a new node, let's say E1 or whatever, N1, let's say N1. N1 equal, use the node class to create the new node with this data value. Now that is created. After creating that, what you have to do is, so you have to copy, right? Copy the head value to this node. That means you can say the new node is N1. N1 node next value will be the head value. That is self dot head value. N1, so self dot head value means this one. This is copied to this one, and the new node, new head will be, then what is the head? Self dot head value will be, head val will be this new node N1. So that's what you want to do when insert to the front. Okay, now let's try, right? Let's try to insert to the front. Let's see whether it's happening. I'm going to, okay, so no need to run that. So let's run the same function here, right? Let's run the same function here. I'm going to, okay, this list one dot insert to the front. I'm going to insert, let's say insert Monday, Tuesday, Wednesday. Let's insert Sunday to make this kind of order, right? Let's insert and let's print it again. After inserting, let's print it again. And before printing, let's keep some space, right? Print after inserting and a new line to separate that. Again, here also new line. Set 2 new lines after. Okay, now let's print this. Let's run this and see what is the output. Okay, you can see it was earlier Monday, Tuesday, Wednesday, someday, and after inserting, it is Sunday, Monday, Tuesday, Wednesday, and someday. Insert to the front is successful. But insert to the rear, you have to like access one by one and go to the rear. If you want to insert to the rear, that means the back end. So what you have to do is you have to go one by one until the last pointer is null. Then you have to do the insertion, because finding rear is not easy. You have to start from the beginning. Start from here, the next node is this one, next node is this one, and next node is this one. Okay, after that only you have to insert. You have to go to the first head node, next node, next node, next node, next node, and you found this is null. So to this point you have to insert. Right? That means you have to sequentially access and insert to the rear. Okay, let me show how this is done. Similar to this one, you have to create a so you have to use the refer to the same object, self and the data, and then you have to create a node similar to this, that is almost similar to this, creating new node. And after that, so you have to first check if this self, that means this object's head value is equal to none, or you can say is none. Is none means this list is empty. This list, if this list is empty, then it's very easy. You can insert the new node there. Then you can say self dot head val is this n1. So that is easy. Then you can return from this function. Else, if not, if list is empty, it's very easy to find the. Otherwise, then you have to find the element. Let's say element equal. I can say the first element is self dot head value, and that is the first element. Then I have to go one by one by one, right? I have to go one by one until, right? Until I reach the last value. That can be done while element dot next value. Element dot next value. If element dot next value is there, then you can just change the element, okay, element by going to the element dot next value. That means you are going next, again, next of next, next of next until you visit the last element. So similar to this here, print val while this is not none, while this is not none, you go to the last element. You go to the, while this is not none, you go to the last element. And then you print the element. Similar to that, here you go to the last element, like one by one. And when you find the last element, so you can say the new element is, sorry, element dot the next value is this n1, the new node which you have created. This can be used to insert to the last element. Or you can, so this has two things, or you can use the same list print example. So let's try for that one or this one. First try for this one and see. First, let's try for this one. And now I'm going to insert to the, after printing this, I'm going to insert to the rear. To insert rear, I'm using this insert rear function. List one dot insert rear. List one dot insert rear, and I'm going to insert, let's say, after Sunday, I'm going to insert Wednesday, maybe Saturday. So let's run this. And now you can see when the result comes after insert, oh, head. What is that head value? Okay. Insert rear. Oh. What has happened? Next value is new node. Okay. Insert rear and okay, you have created new node using the data. That is correct. Then use referring to is none. If it is none, the head value is new node. Okay. Then return. Then element is self dot head value. It is okay. So then while element has next value, You are just here. I have not changed the last element, next value, that is element equal the element dot next value. You are moving one to one. Then you can run this and you can see what's there. And you can see after inserting the Saturday is inserted to the rear. Okay, this can be done in some other way too, right? This can be done. This is not the only method to do this. So let's say def method to insert rear. I'm going to insert rear using method to the self and data. Self and data. Okay, I'm going to create similar to this. I'm going to create a new node with this data. And after that, I'm going to use the search method, which is this one. I'm going to use the search method. In search method, it says print val or not print val, let's say element, element, the head value. Then I'm saying, okay, element is not none. Without printing, I'm accessing the element. Element equal element dot next value. That means I'm just accessing till the end. And after finishing this, I can tell, okay, then please mention this element's next value equal n1. Okay, let's use that method too. Let's use that method also. I'm going to insert another day. Another day will be inserted using this method too. So let's run this. Okay, now you can see the first method, second method, and. Okay, something wrong. Okay, while element is not none, you visit, and visit. And when it is none, will be ended. Okay, what you have to do is you have to include this here. Then again, the problem comes. So when you include this here, the next value will be changed. So that will be endless. So you have to here. So what will happen after terminate, after it will become none only, it will go out. When it become none, you can't set the next value. That is the problem. But in the doubly linked list, you can refer to the previous value and then do this. But here, what you can do something else, right? Here, you don't have way to go back and insert to the last element. That's the problem. When this is so, again, you have to use the same thing. Again, you have to use the when head value is none. While it's not none, you are doing this. When it is none, this will exit when it is none. Then you have to say yes, then you have to set the element dot next value to n1. So this will be complex. Yeah, not complex, but this you have to format a little. Otherwise, it's like you are going to set value to a none. None can element එකට තමයි set කරන්න යන්නේ, but that is not going to work out. So that's the problem. So okay, just forget it. Just try this first. I'll explain the modification after you trying this. Just try this one, insert front and insert rear first. ये देख try करन, right? So if you want to, yeah, if you want to access that, you have to do one before this element. That can be done if like so similar to this one also, that, but again that will be the same. So you can use while element next value, while element next value, then you can just add this one. That can be done. But that can be done. That can be used to insert an element there. But again, the problem is, you can see here. Now you can see another day is inserted at the last. But what is the problem of this code? What is the problem of this code? This code actually it doesn't have this part. So the problem comes when this list is none. When this list is none, so it will give an error. So if you have not inserted the first element, and if you have no second element too, and if you have no third element, likewise, if you have no elements in this, then this list will be empty, right? This list will be empty. At that time, this will give code error, right? Again, because of this one, right? Let's stop this one also. Let's stop this one. Let's stop this one also. Then you can see if in case if list is empty, it will give an error. That is the issue of class code. You can see here, not possible to insert that. That's the issue. That's why you have to use the first method only. So if you can use the second method, but the thing is, if you use second method, that will give an error in case of list is empty, right? Therefore, let's remove this method and reformat the text like this. Okay, now you know how to insert and how to remove element from this. Sorry, basically how to insert. So now you know how to insert to the list, either to front or rear. To insert to middle, actually, I'll explain the code further. So if you want to insert to middle, you can give tree data. That means what is in the middle. You have to give the element which is in the middle, and also the new data. So if middle is none, then the node is not there. If middle has data, then it will create the new node and it will be attached to the middle node's next value. So that is simple. It will attach to the middle node's next value. And the value of the next value will be, so here, the new node's next value as shown in here, as shown here in this one. So we have insert to the middle. Beginning of the list, end of the list, but middle of the list seems here you can see add element to the middle of the list. You have to copy the content here. So whatever the content here, you have to copy it to this node, right? Content here, you have to copy it to here. You can see to insert new node C between new node B and D, copy the pointer field into B, right? Copy the point field into B, pointer to the new node, right? So B, you need to copy that to the new node, and into the point B into the pointer field of new node, which is C. We change the pointer field of B to the new node. So you have to copy the things, whatever the things here. So let me draw here. Okay, this was earlier pointing to the D. This was pointing to the D. But you have to copy this to this one as the new node is now pointing to the D. Now this is pointing to the D. Okay, after pointing to the D, now what you have to do, you have to reference from B to the new node which has created, right? We have to change the pointer field of B to point new node C. So you have to erase that and now you have to point this to C. Understood?
Right.
Okay, so that is the thing which has done in this code, right? So let's go. That is the thing which has done in this code. You just copy the content of the middle node means whatever that B node, you copy that to the new node and then you point that node's next level to or next value to the new node. That is basically the swapping part. And so I have introduced another method that insert into a position. So you can name a position and ask to insert to the particular position. For an example, so if you want to insert the position 6, you can do like this. Mention the position and you traverse to the list and find the position and insert to that position. Right, okay. Then removing the node. Removing the node can be done. Again, you have to traverse from, so if it is none, you can't remove. So you have to remove. So if it is like head val is none, and then if you have to check with the head val whether it's matching the removing key. If head val is not none, then you have to traverse and find whether the removing key is there. If key is there, break, and then you have to point to the next node. So that is simple, but the algorithm is you have to think about the algorithm here. Similar to this, when deleting a node, if you want to delete node D, first you have to find whether D is here. If it is in the head, you just point that to head. If the node that you want to delete in the head, you have to make it to none, equal this to none, then D will be deleted. But if it is in the middle, you can go to next and find if it is in the middle. The deleting means you have to copy the content. You have to copy the content of D node to B node. Right? Copy the pointer field of the node to be deleted to, which is D node, and that should be pointed to this one. So as I drew earlier, the pointer L was here, D point in L. You have to copy that and put it in the B. Now B point in L. B point in L means automatically D will be discarded. Right? Because then from B, the next will be L, because you have copied that to B. That is what we have done in this example. Okay, I'll send this code to you. So what I can do is I'll send this code to you, and this
Right.
has all deleting everything. You can, so but try one by one, right? Don't try all these at once. Try one by one and try to remember
Mhm.
the algorithm, because in the exam, as you said, it can be there. They can ask the algorithm, the method. So that
Right.
is about linked list. Okay, next
Mhm.
day I think we have to learn about the tree and hash table. So that part we'll
Mhm.
discuss on the next day.
Uh, uh, Sir, from that part isn't a part of the AS syllabus.
Sorry.
The binary trees and all aren't part of the syllabus for AS.
Yeah, it's not for us, but I think you need to learn that, no?
Yeah, I mean, sir, since the May June exam is coming up in May, can we start doing past papers?
Right, sure. Sure.
Oh,
So that means you want me to stop from this, or actually pause.
because
Uh,
from school, the AS portion,
mhm.
from linked list is the last one.
Right, okay.
So from after this, can we do past papers?
Yeah, sure. You don't need any other
Okay.
theory lesson to be discussed? No.
No.
Right. Okay. So if possible, so you are going to face AS part only, no? This time?
Yeah.
AS part only, right? Okay.